at the National Taiwan University in Chinese Taipei. He will present on identifying tomato diseases, pests, and disorders by using AI machine vision. So, Dr. Guo, if you're ready, the floor is yours.
Yes, can you see my screen?
We can see the screen and we can hear you too. Thank you.
Great. Good afternoon there, and good evening for the folks in Asia. So I'm Yan Fu Kuo from National Taiwan University, and today I'm going to talk about the identifying tomato disease, pests, and disorders by using AI machine vision. And so tomato is a very important crops that I don't think I need to mention about it anymore. But it usually suffers from like the production suffers from the loss due to disease, pests, and disorders. And there are many cases studies, and you can check it from the screen. So there are two ways to determine what is infecting the production of tomato. And one is that you can see that the farmers take a photo and send it to you and ask you to check what it is. And the other is they send the leaf in, and we do the microscopy examination, which is very time consuming, and we need special equipment. So basically, the most common way is here, that the first one. So, but this is still very time consuming and it takes time. If you receive a photo like this and you're a plant pathologist that you don't respond it very quick. So we are thinking a way to, autonomize this approach. So basically, in Taiwan since 2016, we built up we created smart agriculture. It's a big project. So the idea is that we use sensors to replace the sense from human, and we send the data through IoT device to the cloud over here. In the cloud, we have AI, and AI can do the calculation for what is happening on that leaf. So let's step back a little bit, and what should we start? And so we know that tomato, we can check their fruits and we can check their roots, but these are like it's not easy to check, and the fruits are produced later in their life. So leaf is actually the first one we want to check, but there are different types of leaf. And another challenge is that for farmers, they usually send you only a single photo and ask you to identify what it is. So probably we need to build some AI, I mean multiple deep learning models that will identify the disease in one shot. We only have one shot. So here you can see 17 common tomato issues in Taiwan. This is a subtropical region. So as you see that these disease may not happen in Europe or North America. So this is very area specific. And the most challenging part is actually like this. There are some disease and pests, they look similar in their early stage. Even for the plant pathologists, they cannot tell what is going on in the early stage of this. So the approach that we take is that we group them together. Here you can see, okay, and we group actually 17 disease into 14 categories. And the reason we can do this is that actually what we need to tell the farmers is how to treat the problem rather than tell them exactly what is going on their tomato. So this is the common pesticide that you can use on each category. So as I said that we use 5 deep learning models working together automatically. And one instance messenger that's called Line. It's very common here in Japan, Korea, and Taiwan. And we also have some database. And I also have a large language model, but I will go through the computer vision model first. So 5 computer vision models together. So first thing we have to do is to collect enough data. And in the past 5 or 6 years, we collect more than 10,000 images in the fields, greenhouses, around in different areas. So this is a big job. And then the first model is called anomaly detection. Say, if our system receive an image like this from the farmer, this is basically too far away from each individual, so there's nothing we can tell. We call this kind of image anomaly image, and then we return the image to the farmer and say, you have to take another photo. And an image like this are okay. That's the first model. And second model is that since we want to do this in one shot, so we have to determine if the image that we receive is a compound leaf or it's a leaflet. So this is the purpose of the second model. And once it is determined it's a compound leaf, then we have to identify what kind of issue it is. It can be healthy, can be infected by a virus, and it can be like too much phytohormone. So this is called compound leaf diagnosis model. And the fourth is the leaflet diagnosis model. This is for some photos that the farmers take a close-up photo of a single leaf, and you can see what is happening on the leaf surface. Okay. And for the leaflet diagnosis model here, we use so-called YOLO model, usually call it localization classification model, such that using this model, we can identify different disease on a single leaf. So this is the fourth model. And the fifth model is for that kind of a disease that is very similar on the upper surface. We can ask the farmer to flip over the leaf and check the lower leaf surface, and then we can identify what exactly the disease is. So altogether, the 5 models, their accuracies, all of their accuracies are higher than 90%. And then we create a service on our server, and so we stream the results to the line that I just mentioned. So here you can see this is the identification results. And here are some hyperlinks. Once you click them, it takes you to the web page of the pest site. So that's what is happening in the past 5 years. Now we have to move forward. Now, in a previous work, we only identified the disease and telling what the disease and maybe the like a pesticide that the farmer can use. But what if the farmers want more information? Then we need generative AI, basically large language model. So there are 2 major functions there we are using from the large language model. First is the reading comprehension. The LLM must understand what the farmer is asking. And second is content summarization. And why do we need content summarization? Because we use one approach called RAG, the retrieval augmented generation. The approach actually take the question and search the document in the database that has similar content with the question or the query. Okay, and then send the document back to the large language model for summarization. And this is called trustworthy generative AI, and this is very important. So here we can put the 2 services together using one entrance. This is the entrance. So the farmer can, if the farmer provides the image, then we call the computer vision model to identify what it is. If the farmers provide some text, type some text, then we use the RAG service that we have. So I would like to acknowledge my team, my student working on this and help me to achieve this work. And this is my presentation. Thank you very much.